Two rays with a common starting point form an angle. You see angles in all walks of life. These angles can be of many types. Let's look at some basic types of angles and the methods to measure them. Let's begin with one of the most common angles that we see, the right angle. Why is it called a right angle? Try this activity and you'll see why. You are already familiar with directions: east, west, north and south. Here is a big compass. Suppose you were standing at the center facing north. What would you do if you needed to turn east? Turn right or take a right angle's turn? Can you recall where else you have seen right angles around you? Here are a few examples. So, why are right angles important? Well, think about it. What would your world look like without right angles? Something like this, perhaps? But what happens when you join two right angles? You'll find out if you turn south. It requires another right angle's turn. At this time, the segments that make the angle actually form a straight line, NS. Guess what angles you've made? This is what is called a straight angle. A straight angle is formed when you turn through two right angles. If you turn through another straight angle now, you will reach right back to where you started in the first place, that is, facing north. Thus, two straight angles make a complete turn, also called a revolution. You can also say that two straight angles make a complete angle. Can you think of an object that makes a complete angle? Remember how the hands of a clock start at 12 and then end up at 12 after taking a full round of the clock? It makes a complete revolution. Do you know how the phrase "working round the clock" came into being? Each hand of a clock goes through a complete revolution in 12 hours. Therefore, if somebody works for 12 hours non-stop, he is said to have worked round the clock. What is the angle travelled by the hour hand of a clock between 12 noon and 6 p.m.? Between 12 noon and 6 p.m. is a straight angle. 5 p.m. and 8 p.m. Between 5 p.m. and 8 p.m. is a right angle. 3 p.m. and 9 p.m. Between 3 p.m. and 9 p.m. is a straight angle. 3 p.m. and 6 p.m. And between 3 p.m. and 6 p.m. is a right angle again. Can you group these angles into right or straight angles? Difficult, right? Some seem bigger and others seem smaller than a right angle. There is an easy way to check whether an angle is a right angle or not by using a right angle tester. You can create your own tester. Take a piece of paper and fold it as shown. Your right angle tester or RA tester is ready. Want to try it? Consider this kite. Line segments AB and AO make an angle. Let's check this angle. We place the RA tester at this corner. As you can see, the edges of the tester don't match with the corners of the kite. That means the lines on this corner do not form a right angle. But if not a right angle, what angle is this? Well, let's see. The angle we just measured seems smaller than a right angle. That is, it seems to be less than 1/4 of a revolution. Such an angle, smaller than a right angle, is called an acute angle. Here are some more examples of acute angles. Which of these angles are acute angles? And how about this angle? Shall we try the RA tester on it? It seems more than 1/4 of a revolution, but less than half a revolution. That is, it is larger than a right angle, but smaller than a straight angle. Such an angle is called an obtuse angle. Here are some more examples of obtuse angles. Can you identify all the obtuse and acute angles in this figure? There, the angles marked A are acute and angles marked B are obtuse. Finally, let's consider this angle. It's even larger than a straight angle. It's a reflex angle. An angle that lies between the straight angle and the complete angle. For example, when it is 7:15 on the clock, the angle formed by its hands is a reflex angle. Based on the type of angles you have learned so far, classify the angles shown. Here is the correct categorization. Can you make out what type of angles these are? You know the difference between acute and obtuse angles by now. Let's go one step further. Which of these acute angles is bigger? And how much bigger is it? To answer this question, you need an exact measure of each angle. An angle is measured in degrees. One complete revolution is said to be 360 degrees. So, if you divide a complete angle into 360 parts, each part will be a degree. With this knowledge, let's go back to the exercise we did with the compass. If a complete angle is 360 degrees, how many right angle turns are required to make a 360-degree angle? A complete angle requires 4 right angle turns. So, 4 right angle turns are required to make a 360-degree angle. Which means the exact measure of a right angle is 1/4 of 360 degrees, that is 90 degrees. You turned through a straight angle to face south, and then another right turn to face west. What is the angle you have turned through? You have taken 3 right angle turns, so the angle you have turned through is equal to 3 right angles. That is 90 degree into 3 or 270 degree. But what if you didn't take a complete right turn and stopped somewhere in between? What angle are you making now? Probably half of a right angle, that is 45 degrees. But how will you know for sure? You can verify such measurements using a protractor. In fact, you can create your own approximate protractor. Take a circular sheet or cut one out using a small circular shape. Fold it twice to form what is called a quadrant. When you open it out, the fold in the semicircle represents 90 degrees. Label this fold. Fold the sheet again, but this time fold it 3 times. The fold on the quadrant will give you 45 degrees on one side and 90 plus 45 degrees, that is 135 degrees on the other side. Similarly, by folding it further, you can label the 22.5 as well as 157.5 marks on the sheet. Thus, your approximate handmade protractor is ready. Now, let's measure the angle where we moved approximately halfway between north and east on the compass. Place your protractor so that the midpoint of the protractor lies on the vertex O of your angle NOA. Align OA with the straight edge of the protractor. Now, does ON coincide with the 45-degree line on the protractor? Almost, but not quite. Looks like angle AON measures a little more than 45 degrees. So, how do you get the exact measure? Here is where your ready-made protractor can help you. Let's examine this protractor. Unlike the 6 divisions on your handmade protractor, this protractor has 180 equal parts, each representing a degree. It has 2 sets of markings. One set starts from 0 degrees on the right side and ends with 180 degrees on the left. The other set has the same markings in reverse. Now let's use this protractor to measure angle AON. Place the protractor with its midpoint lying on the vertex of the angle. Align the straight edge of the angle with the straight edge of the protractor. Read the scale that has the 0-degree mark coinciding with the straight edge of the angle. The mark shown by the other line segment on the curved edge is the measurement of the angle. The angle is 48 degrees. In a rotation, a right angle corresponds to a quarter turn or 1/4 of a turn. When you take two right angled turns, you form a straight angle. A right angle tester can be created by folding a piece of paper twice. If the edges of the RA tester coincide with the line segments forming the angle is a right angle. An angle smaller than a right angle is an acute angle. An angle larger than a right angle but smaller than a straight angle is an obtuse angle. An angle greater than a straight angle but less than a complete angle is a reflex angle. An angle is measured in degrees. One complete revolution is 360 degrees. If you divide a complete angle into 360 parts, each part will be a degree. An approximate protractor can be created using a circular piece of paper and making its folds. To measure an angle using a protractor, one, place the protractor with its midpoint lying on the vertex of the angle. 2. Align the straight edge of the angle with the straight edge of the protractor. 3. Read the scale that has the 0-degree mark coinciding with the straight edge of the angle. 4. The mark shown by the other line segment on the curved edge is the measurement of the angle.